Hey everyone, welcome back to another machine learning tutorial. In this video, we're going to cover everything you need to know about the evaluation metrics for logistic regression. So if you're ready to take your classification skills to the next level, then let's get started. Alright, to kick things off, let's talk about what logistic regression is. Basically, it is a classification algorithm that uses a sigmoid function to predict the probability of an instance belonging to a particular class. Now, it's commonly used for binary classification problems, but it can be extended to handle multiple classes as well. And it works by finding the best fit line in n-dimensional space, where n is the number of features, and then it uses this line to calculate the probability of an instance belonging to a certain class. Now, once you have your logistic regression model trained, the next step is to evaluate its performance. But wait, hold up. Before we dive into the details of the evaluation metrics, there's something really important you need to consider. Are you using the right one for your specific use case? Well, let us explore some of the most common metrics you can use to evaluate the performance of logistic regression. And let me tell you, they are super useful for all kinds of classification problems. But first, before we move further, please subscribe if you haven't already done it. Also, remember to press the like button if you enjoyed this video. These steps will help you stay updated with all our latest videos. Okay, so let's start with accuracy. It is the most commonly used metric for evaluating a classification model, and it is basically the ratio of correctly predicted instances to the total number of instances. So if out of 100 instances, your model correctly predicts 80 of them, then the accuracy would be 0.8 or 80%. Sounds pretty straightforward, right? Yeah, it is. But accuracy alone can be misleading. Why? Well, let's imagine you're working on a problem where one class dominates, meaning there's way more instances of that class than the other. For example, in a dataset of credit card transactions, 99.5% of them are non-fraudulent and only 0.5% are fraudulent. If your model just predicts everything to be non-fraudulent, it would still have an accuracy of 99.5%, even though it's completely useless since it's not identifying any fraudulent activity. So yeah, accuracy isn't always the best metric to use, especially when dealing with imbalanced data sets. But don't worry, there are other metrics that can give you a better understanding of your model's performance. So stay tuned and let's keep exploring together. Next up, we have precision and recall, which are super important metrics when it comes to classification problems. They are often used together because they provide a more comprehensive view of your model's performance than accuracy alone. Let's start with precision. It basically measures how many of the positive predictions made by your model were actually correct. So out of all the instances your model predicted as positive, what percentage was actually positive? That's the precision. To calculate it, we use this formula. Precision equals true positives divided by the sum of true positives and false positives. A high precision means that your model is good at avoiding false positives, which is super important in some cases like spam detection or fraud detection. For example, if you're rebuilding a spam detection system and your model marks an email as spam when it actually isn't, that could be a big problem. In this case, you want your model to be highly precise so that you don't accidentally mark important emails as spam. Now let's talk about recall. Recall, also known as sensitivity, measures how many of the actual positive instances were correctly identified by your model. So out of all the positive instances in your data set, what percentage did your model correctly predict as positive? That's the recall. To calculate it, we use this formula. Recall equals true positives divided by the sum of true positives and false negatives. A high recall means that your model is good at catching all the positive instances that are present in the dataset. This is important in scenarios where you want to make sure that you don't miss any positive cases, such as in medical diagnosis or fraud detection. For example, if you're building a fraud detection system and your model misses a fraudulent transaction, that could be a big issue. In this case, you want your model to have a high recall so that it doesn't miss any fraudulent activity. So yeah, precision and recall are super important metrics to consider when evaluating your classification model. And the best part is that they are easy to understand and interpret. Just remember that precision measures the accuracy of positive predictions, while recall measures the completeness of positive predictions. By considering both metrics, you can get a better sense of how well your model is performing and whether it needs some fine-tuning. And hey, if you're enjoying this content so far, why not hit that like button? It really helps us grow and bring you more awesome machine learning tutorials. Next up, let's talk about the F1 score, which is basically the harmonic mean of precision and recall. It gives you a single metric that summarizes the overall performance of your model, taking into account both precision and recall. So why use the F1 score? Well, it is great for situations where you have an imbalanced data set or when you need to balance between precision and recall. For example, if you're rebuilding a system to detect rare diseases where it is important to not miss any positive cases, but also to avoid unnecessary follow-ups due to false positives. The F1 score is a great metric to use because it considers both precision and recall. To calculate the F1 score, we use this formula: F1 score equals to multiply precision multiply recall divided by sum of precision and recall. It's always between 0 and 1, where 1 is the best score possible. The F1 score is a really handy tool to have in your machine learning toolkit, especially when you're dealing with imbalanced data sets or when you need to balance between precision and recall. Okay, so you've probably heard of the ROC curve and the AUC. So let's explain what they are and why they are useful for evaluating logistic regression. First, let's define the terms. The ROC curve stands for Receiver Operating Characteristic, and it is a graphical representation of the model's ability to distinguish between two classes. It's created by plotting the true positive rate against the false positive rate at various threshold settings. So here's what's going on. The true positive rate, TPR, also known as sensitivity or recall, measures the proportion of actual positives that are correctly identified as positive by the model. On the other hand, the false positive rate, FPR, measures the proportion of actual negatives that are incorrectly identified as positive. So as we vary the threshold for our model, the TPR and FPR change accordingly. Plotting these values gives us the ROC curve. Next, let's talk about the area under the ROC curve or AUC. Essentially, the AUC is a single value that summarizes the overall performance of the model. It represents the area under the ROC curve, and it ranges from 0 to 1. An AUC of 1 indicates a perfect model that correctly classifies all instances, while an AUC of 0.5 represents a model that performs no better than random guessing. The higher the AUC, the better the model is at distinguishing between the two classes. Using the ROC curve and AUC can be super helpful for comparing different models and evaluating their performance. Plus, it's not affected by class imbalance, making it a great choice for imbalanced data sets. So if you're looking for a powerful tool to evaluate your logistic regression model, definitely consider using the ROC curve and AUC. So let's talk about log loss. It is a metric that measures the performance of a classification model by evaluating how well the predicted probability distribution over classes matches the actual class distribution. So essentially it quantifies the difference between the predicted and actual label distributions. To calculate log loss, we first need to predict the probability of the input data belonging to each class using the sigmoid function. Then we compare these predicted probabilities to the actual class labels and calculate the loss. The lower the log loss, the better the model performs. One cool thing about log loss is that it's differentiable, which means that it can be used to train models using gradient descent or other optimization algorithms. It's also very versatile and can be used with various types of models, including logistic regression, decision trees and neural networks. However, it is important to note that log loss is not recommended when dealing with highly imbalanced datasets, as it tends to favor models that predict the majority class. Despite this limitation, log loss remains a popular metric for evaluating classification models due to its ability to provide a single value summary of model performance and its compatibility with various optimization algorithms. So now you know 5 of the most important metrics for evaluating your logistic regression model. Remember that the best metric to use depends on the specific requirements of your project. If your data is balanced, accuracy or the F1 score can be great choices. While if you're dealing with an imbalanced dataset, consider using precision, recall, or the ROC-AUC. And if you want to see how confident your model and about its predictions, try out log loss. No matter which metric you choose, make sure to understand its strengths and limitations and always evaluate your model thoroughly. And hey, if you found this content helpful, why not hit that thumbs up button and share it with your fellow learners? It's a simple way to support us and help others discover new learning opportunities. Thanks for joining us on this journey, and we'll catch you in the next one.